So let me go over a couple of examples from your homework about end behavior. If you have your sheets from class, that would be tremendous help. If not, um, then you'll want to watch the video that I posted that just sort of reviews with you end behavior. So number 7, f of x, this is number 7 from your homework, f of x equals 2x squared minus 8x plus 2. Remember, there's two things we need to check. Well, there's one thing we need to check. We need to first make sure that this equation is in standard form. So we want to make sure it's highest power to lowest. So notice I have f of x equals 2x squared minus 8x plus 2. So my highest power is first, and then I go to the lowest. So we can use this leading term, the 2x squared, to determine what our end behavior is going to do on the function. So and so to do that, we're just going to look at what's the leading coefficient and what's the degree. So remember, the leading coefficient is the number out front. So the leading coefficient in this case, the number out front of x squared is 2. And this is positive. And then our degree is even, it's 2. So the degree is even. So this was a quadratic. So we know the basic shape of this is going to look something like this. It's a quadratic, come down to something like that. So we can pretty accurately describe the end behavior, even if we didn't know what happens in between the two end arrows. So even if we just knew which way it goes, we still have an idea of what's going on at the ends of the graph. So I'm going to make this my x-axis, and I'm going to call this y, and I'm going to call it f equals f of x. This is the notation that we use when we describe end behaviors, this f of x notation. So I'm going to include on this graph something that will hopefully help us a little bit, is I'm going to put plus infinity. So this just means that if I was to go forever to the right on my x-axis, I would be going to positive infinity. Similarly, if I went forever to the left on my x-axis, I would be going to negative infinity. Your y-axis, we could do the same thing. If I go forever up on my y-axis, I would be going to positive infinity. So I'll write plus infinity. And if I were to go forever down on my y-axis, I'd be going to negative infinity. Okay. So here's what your homework wants. It says, so it wants to know what happens at each end of the graph. So we'll say as, and your homework is going to be written a little different than I'm writing it here, but we'll take care of that at the end. So as, let's start with our x's. So as x approaches positive infinity. So as we go to the right, as in other words, as our x's increase, what's happening to our y's? In other words, what's happening to f of x? So remember, this is just a fancy term for saying my y's. So if I pick a random point, let's say I start here, and I go to the right, are my y's increasing or decreasing? And hopefully you can see these dots that I'm making are going up. So this will be going to plus infinity. And then as x's get smaller, so as x's approach negative infinity, what happens to your y's? In other words, what happens to f of x? So if we start at that same point and we go, this time instead of going right, we go left. So notice as I go to the left, I'm going up. So the way we say up is this plus infinity. Now I said, and this is all that you would be expected to do for numbers 7 through, I think it's 7 through 10. This is all you're expected to do for those ones. Now, your homework does this in a little bit different of notation than what we used here, or a little bit different of order than what we did here, and I'm going to show you that the difference. So in your homework, they want you to start with the f of x part first. So basically, at the very end, you just need to take this part and write it first, and then take this part and write it second. So we're going to rewrite this first statement as, just so that it matches with your homework, as, we'll start with this part first, f of x goes to positive infinity, x goes to positive infinity. And then same thing with the bottom part. we'll write this so this part is first and this part is second. So as f of x goes also to positive infinity, x goes to negative infinity. Sort of weird notation your homework's using. This is the way I have it in blue is more common, but it's not hard to go from one to the other. You just got to switch their spots like we did. So this would be the answer that you're looking for number 7.